Hey, Carl, how you doing? Good to see you. How's school going? Nice, nice. All right, so I saw that you said you're having problems with some math problems. All right, let's go ahead and pop those up and see how we can help you. Let's go ahead and share that with me. So let's see, you said number one. So I guess it looks like you're having troubles understanding fractions and how they work, right? Okay, okay, perfect. Let's go back and pop up that whiteboard and we'll get started. All right. So when we look at fractions, they can be a little scary to think about when we see them because they don't look at all like the numbers we're used to, like one, two, or three, right? But if we get a better understanding of their basic function, I think it becomes a little easier to understand, right? So basically, when we talk about fractions, it's it means that it's a part of a whole, right? So in another case, if we think about, for example, if we were to draw one box, this is one box, right? Or one thing. So this box can be any object. It can be a table, it can be a chair, right? It's just, but in this case, we're using the box to give the example. Now, this box in this case, when we talk about fractions, it means that we can split it. Now, according to the fraction theory, any object can be split infinite amount of times, meaning you can split it as many times as you want, as small as you want, but you can never stop splitting them. All right, but we're not really gonna worry about that, but that's the basic idea of fractions. Right. Now, when we split something, the the number of times we split it is usually called a denominator. Right. So for example, if we're to split this box into four, our denominator would be four. Now, the pieces that we shade in would be considered a numerator, right? So in this case, let's say we have four because we have four pieces, and then we decided shade two, right? Our top would be two. Therefore, our fraction for this concept is 2/4. Okay. Now, a lot of people would say we're done, right? But we can actually simplify this fraction a little bit more. All right. So remember your timetables. This is why it's important that we memorize our timetables and that we know it, because as we progress in math, multiplication will become more relevant. In this case, this particular fraction can be simplified. Now, not all fractions can be simplified, only the ones that have a factor in common, as we call it. Now, to find a factor, we have to use our timetables, right? So when we say a common factor, we have to find a number that multiplies into both 4 and 2, right? Now, when we think about 4, what are the different numbers that we multiply for by? Or what are the different numbers that, sorry, not that multiply, but that go into 4 and 2? That, so in this case, what number can go into 4? So actually, we're talking about division now. Sorry about the multiplication, division. So what number can go into 4? Right? So we think our timetables. So what numbers multiply into 2? So does 1 does, now does 2 does 2. So We go into 2. The good thing here is that we don't have to go, we don't have to really jump that much because so we think about, for example, for 4, we have 1 and 2, right? And what else? And then anything goes into 4 and then 4, right? Now we go to 2, and what do? 1 goes into it, 2 goes into it, and that's it, right? Now what we're looking at is the common factor. Now here we do have 1 and 2, but now we're actually going to stick with the highest common factor. In this case, it's going to be 2, right? Now, how many times does 2 go into 2? Let's put. I'm gonna start down here. So bring this down here. Goes in once, right? How many times does 2 go into 4? Twice. So we're left with this new simplified answer, right? Now, I know you might not see now, but this is actually the same as this. So if we draw this box out here, another box here, now with the different fraction, right? We'll start seeing how they're the same, even though they have different denominators, different numerators. So in this case, again, we're gonna go back and we said that the denominator is the number of times it's split, right? So in this case, we're gonna split this box twice, 1, 2, right? Now it says that one side is shaded. We're gonna shade one side, right? Now, if we look at our first box, do you see how they're the same? Now, let me do this. If I shade all this side, now this, now we can see that the shading is equivalent now, right? And it's the same, which is 1/2. All right. So that's a little bit of fractions. So let's go ahead. I know it can be a little kind of difficult to understand, especially when we're first understanding fractions, but let's go ahead and do a couple examples, and then we'll see how much you get out of it, and then we'll try to make sure that you understand it. All right, so let's go ahead and do some examples. I'll do some. All right. All right, perfect. Now let's move on to the next one and see what else you need help. So let me see. Stop sharing and then. So it looks like you need help with subtraction and then division. All right, so let's go ahead and do the easier one, and then we'll work to our way up. 302, 1897. All right, so let's go back to our whiteboard. All right, let's clear this. You wrote all these notes down. And I'm gonna clear it up. Perfect. Now let's write the 3002. 1897. Okay. Perfect. All right, now I think I know why you have having a problem with this, but what about this problem is it that bothers you? The 2 zeros in the middle? Okay, that's what I thought. All right, so just like any time we're approaching a subtraction problem, we always want to see we always want to see We always want to approach it and make sure if the top is smaller or bigger than the top. If it's smaller than the top, then that means we have to borrow, right? But in this case, it's different because we have the two zeros in the middle. So that means we have to go all the way to 3 and start borrowing so we can answer these questions. So in this case, what I mean is we're going to borrow so a 1 from the 3, so it's going to turn it into a 2. We're going to bring over the 1, and just like you do on the other subtraction problems, again, you're going to borrow, and this is going to turn into a 9, right? And what does the other one turn into? A 10, exactly. Now we've reached the end. We still need to borrow for the 2, so we're going to have to borrow one more time. Turn this into a 9, and then turn this into a 12. Now, does it start? Now, let's pause for a moment. Does it start looking from now like we can solve this? Yeah, right. So now let's start solving this. So 12 minus 7 is what? We can use our fingers, or if you got it, 8, 9, 10, 11, 12. So it's going to be 5, right? So now 9 and top and 9 at the bottom. So yeah, you can subtract. So it's 0. Right, another one. So 9 minus 8 is 1. And then 2 minus 1, the top is bigger, so we can subtract the bottom. So 2 minus 1 is 1. So your problem is going to be 1102. Okay. Any questions? Let's go ahead and try a couple more and see if we figure it out. All right, perfect. So let's clear this. All right, so let me see what we got going next. Division. Let's see. 5 divided by 3502. All right, so let's go back and pop up the whiteboard. Perfect. So got 5 divided by, let me clear this, make it go more up top. So 5 divided by 3502. So let's go ahead and write down our function, or the steps that we have to do when we do division, right? And the first one is what? Remember? Do you remember 30 monkeys smell bad, right? So 30 monkey smell bad. This means division, multiplication, subtraction, and bring down. All right. So make sure we remember that. We always want to remember these steps. That's what's going to take us to solve this question. Again, this is why it's important that we practice our division and our multiplication. Okay, so in this case, we're going to start with division, and we're going to start by making sure that we get to the first point where 5 can fit into the number, right? So in this case, if we start right away, does 5 fit into 3? No, right? So we have to keep on adding a number. So we go back and we add the 5 right here. So does 5 fit into 35? Yes. So we write down the 7, right? So now we've divided. So what's our next step? Multiplication. So we're going to multiply 5 times 7, which is 35, right? And now, since we multiply, what's our next step? Subtraction. So now we're going to subtract 35, which is 0. Right? What we're going to do is bring down, finally, our last step is bring down the 0. Right? Now, does 5 fit into 0? How many times is 5 into 0? 0 times. So we're going to go over here, and we're starting the process all over. So this is division. Does 5 fit into 0? No, so it's 0. Sorry, 0 times. Right? Now we divided. Now let's multiply. So 5 times 0, what is it? 0. Perfect. Now let's subtract. Minus 0. Right? Now what's the next one? Bring down. So we're going to bring down the 2 all the way down here. So it's 2. Okay, so we're going to start again our concept. So we're going to ask, does 5 fit into 0? How many times is 5 into 2? 0 times again. Right, so 5, now we're going to multiply. 5 times 0 is 0. We're going to subtract. It's going to be 2. And then we can't bring no more. We can't bring no more numbers, or our final answer is going to be, sorry, 700. Remainder 2. So 700. Sorry. 700. Remainder 2. Okay, so right here, it's important that we don't forget our process, our steps, and we follow them. Okay. Oh, and the other thing I forgot to mention, now that I'm looking at it, sorry. When we're dealing with fives, what's one of the rules about fives? Do you remember? What do all multiples of 5 end with? They end with the 5 or 0, right? So in this case, if we look at what we're trying to divide 5 into, and we look at the last number, in this case it's a 2, right? Is that 2 or 5 or 0? No, so what that indicates is that when we have our final result, we're going to have some remainders. So it's not going to go in smoothly. All right. Now, if that were to be a 0, and we were to be left over remainders, then that would indicate that we did the problem wrong. Right. So that's kind of another kind of tip to know when you're dividing by 5. All right. Any questions? All right. So let's go ahead and move on to the next question. So let's go pop up the question again. Sorry, let's go ahead and pop up those questions. So next we're talking about rates and ratio. So go ahead and share with me your pull up your example here. So it's 2.2. Two. All right. So let's take a look at this. Can you go ahead and read it for me? And then we'll write it down. Okay. So this one can be actually quite tricky, right? Because it's gonna require us to actually do an extra step outside of what we usually do when we talk about rates and ratios. All right, so let's write these down. So we got Allison, right? That is going 2.5 inches every 5 days. Inches. Then we have Yuki, whose plant is growing 5.5 centimeters per 4 days. And so they're asking us which plant is going faster, right? Okay, so let's go ahead and pop up back on the whiteboard. Clear this up. And see how we can solve this. Now, before we start, do you remember what distinguishes a rate and a ratio? Right, so ratios are usually more simpler, they're fractions, but they're still the same. They're still calculated the same. Now, the only difference between a ratio is that we usually tend to add a time and a measurement to it. So in this case, if we look at it, what they're giving us is for Allison, they're giving us 2.5. And then they have inches for 5 days. Right. In this case, because they're giving us days in inches, then this would be considered a rate. So this is the rate at which the plant is growing, 2.5 inches for 5 days. All right. Now we look at Yuki. Her rate is 3.5. Sorry. No, it's not that. Rate is 5.5 centimeters for 4 days. All right, so let's write those down because I don't know if we have enough space here. But now what's asking us is, the question is which rate is growing faster? All right. And this is, I guess, what we're going to try to figure out. All right. Now, what about the problem, or before we start, is there a particular area you're having problems with? Oh, so you're trying to figure out how you can simplify to compare them? Okay, that's a good question. But before we start, there's actually in this question, like I said, it's it's a little different because if we look at the measurements on the top, which is the numerator, are inches the same as centimeters? No, right? So in other words, for us to better understand what the rates are telling us, we have to transform one of these. We either have to transform into inches or into centimeters so that we can start really compare them, right? In this case, I would think that the easiest way to do is to transform the centimeters into inches, right? Because the smaller the ratio becomes, the easier they are to understand. That's why when we simplify it, that's why it's always better to do a simplified answer. All right. So in this case, we have 5.5 centimeters. So how many centimeters fit into an inch? So let's go ahead and Google that. Centimeters into inches.
1 centimeter is equivalent to 0.
1 inch is how many centimeters?
1 inch is 2.54 centimeters.
It's 2.54 centimeters. So let's use that calculation. 2.54 centimeters. Let me erase this. We'll go back to this. Or actually, let me erase this part. Just do that. All right, so we're gonna stick with this, and we're gonna turn 5.2 inches divided by 2.54. Right. Sorry, centimeters divided by 2.4 inches. No, sorry, cents. Right, 2.4 centimeters, one is equal to 1 inch. Right. So we're gonna have to figure that out. So let's go ahead and we can use a calculator for this, right? Because we don't know how to divide fractions yet. So let's do 5.2. So we want to take out your calculator. Then we're gonna divide it by 2.54, which equals 2.04. Right, inches. So that can be inches. 2.04 inches. So our new equation or ratio that's going to equal to the centimeter is going to be 2.04 inches 4 days. That's a new rate. All right, so let's see that 2.5 days. All right, so now let's clear all this and just rewrite everything. So let's rewrite this and we'll write our new ratio. And then we're gonna bring back Allison's ratio to compare them. All right, to all drawings. So now that we have similar inches, we're gonna go ahead and compare. So we have 2.5 inches for Allison now for 5 days. Now we have our new rate, which is 2.04 over 4 days. Right? Now, this is Yuki, sorry. When we talk about fractions, now that we have our new rate, now we can start comparing them, right? Now, we can already compare them, but we can actually simplify one of these, right? So I know we have a decimal, but in this case, let's go ahead and ignore the 0.04 because it's such a small decimal. And let's just simplify the 1/4 and see what that simplifies into. So which number goes into both of them? So it's gonna be 2, right? So 2 goes into 2 how many times? Once, and then let's actually add 04. And then 102 go into 4 twice. And then days. And then inches. Right? So our new fractions can be 1/2. So now let's go here in the bottom, start comparing. So let's draw them out because we can't really break this down. We can't simplify 2.5 and 5 like we can 2/4. So now let's break it down to boxes. So we have let's do box. We have a box here, be Allison's, and then we have a box here, which is Yuki. Right now here, our numerator, our denominator is 2, so we got 2 boxes, and we can highlight that. So that means that half of the box is highlighted. So now let's do over here 2.5, maybe a little bit more because it's 2.4, right? So it's actually a little bit more. And then here we got 5 boxes. We got to divide into 5, so it's gonna be tight. It's gonna be 1, 2, 3, 4. Right now. So let's go ahead and highlight. Now let's go ahead and color them. It's half of 2, so be half. Right? So which one of these is more? It's gonna be 2.5. It's gonna be Allison, right? So that's our answer. All right, so